we're going to be talking about Venn diagrams. Now, with Venn diagrams, um, it is somewhat, or it is a lot like the compound inequalities that we had. These are the notes that we had last week. And oops, it's in a different section. I'm sorry. Let me see. And if we look at section 9.1, we actually used, and I want to blow this up for you. See that? We used a Venn diagram to talk about intersection, and we also used a Venn diagram to talk about um, unions as well. So today what we're going to do is we're going to use a Venn diagram to solve a word problem. And I love Venn diagrams. They are great for presentations. I think you can even create these probably in PowerPoint. I'd be surprised if we couldn't. But they're a great way to communicate information. So what we're going to do is just with this example, if C, we're going to have a few, we're going to have a few groups defined, right? We've had groups before, and we looked at, or sets, set A and set B from 9.1, looking at compound inequalities. So we're going to first start by defining a few sets. And each set is going to be represented by one of the circles that you see in the Venn diagram. So the first set that we have, it just reads that if C represents individuals with a college degree. Okay, so C represents the individuals with a college degree. And S represents the individuals earning at least $40,000, sorry. We can use a Venn diagram to display the information. So let's go ahead and read what we're going to work with. If we know that 4,800 individuals have college degrees and 5,400 earn at least $40,000 and 1,200 or 1,200 have a degree and make at least $40,000, then the number of people who have a college degree and do not earn at least $40,000 is fill in the blank. So what we do know here is we want to find out the number of people that have a college degree and do not earn $40,000. So we're going to use this Venn diagram and we're going to start filling in the information. We know that C represents the college students with a college degree. All right, so it's good to make sure we know what the set C stands for. I'm going to label this first circle with a C. And I know that every one of the students that is accounted for, each student accounted for in that set has a student or has a college degree. And I also know that S represents the individuals earning at least $40,000. That's another set. So I'm gonna let the second circle be the individuals that earn at least $40,000. Now, what I also notice is we are given a few values. I know that a total of 4,800 students have college degrees. Now, what does this Venn diagram represent? Well, let's talk about it just for a little bit. If I were to look at this part where they overlap, now that would be the group of students that is in both sets. So they are the students that have a college degree and make $40,000. If I were to look at the set that we have out here, it's the set in C that is not in the overlap. Okay, well, this would be the set of college students that do not make $40,000. And if I were to look at the third part of this Venn diagram, this third part would describe the number of individuals that make $40,000 but do not have a college degree because it's not in the overlap. So when we look at this Venn diagram, we're going to fill it in with the information that we know. So we know with that 4,800 students that that's going to be the sum of all of the students inside. All of them have to be 4,800. We also would then look at more information. I know 5,400 earn at least $40,000. Now that means that the sum of everything in here, the sum of the numbers in here, is going to have to equal $5,400. So they give us a little bit more information. And the other information that they have that is very important is this number right here, this 1,200 or 1,200. 1,200 have a college degree and make 40,000. That is the part that is in this intersection. That is the number of students, and we can write it in there that we know that there are 1,200 students in that section, because that's the number of students in the overlap. Now, what does that mean for the other two sections? Well, let's start over here with the students that have the college degree, right? But they don't make $40,000 a year. How are we going to find it? Well, what I'm going to do to find it is I'm going to take the total number of students that are in C, the total number of students that have a college degree. And from that, I'm going to subtract the students that are in both C and S. So these are the students that are in the overlap. Now what I end up having is 3,600 students do not have a college degree or have a college degree and do not make and do not make $40,000. Sorry. Now notice when we add the two, okay, when we add the two, everything that is in here, just looking at this circle, I get a total of 4,800 students. Okay, that's the number of college students in our study. Now we have one more section to fill out, and that section is right here. It's the number of people that make $40,000 but do not have a college degree. So when we look at this, how do we find that number? Well, they tell us, or we are told, that there are 5,400 individuals that earn at least $40,000. So we're going to start with the 5,400, and we are going to subtract from it 1,200. Okay, the students that are in the overlap. And when I do subtract them, I get 4,200. So this section out here, the green, is 4,200 individuals make $40,000 a year but do not have a college degree. And notice, I want you to notice one thing here. The people in this group, if we add them together, we get 5,400. So every number in that circle added together has to be the total number of individuals make $40,000. So our Venn diagram is completely filled in. And so I want to go back and take a look at answering the question. All right, starting here, it says the number of people who have a college degree and do not earn at least $40,000, excuse me, will be this yellow section. Because it's in the college degree, excuse me, but it is outside the section of individuals that make at least $40,000. So the answer to our question is this. 3,600 excuse me, people. have college degrees, and but do not make $40,000. So this would be the answer to our question. That would be it. Now, a tip, okay, a tip that will help you and benefit the filling in of the Venn diagrams. When you do a Venn diagram, start in the middle. Look for the numbers that are in the intersections of all the groups. Whether there are 2 groups, we're going to look at one that has 3 groups today. So that's what you'll want to do, right? And then you can fill out. So you start in the middle and you work your way out. If you were to rewatch this, I started with that 1,200 first. What was in both? And then I used subtraction to find what was on in the other sections. Excuse me. So we don't only have to, we can use these to answer a question, but we can also use these to answer different types of questions as well. So let's go on to the next example. Suppose we want to mail a questionnaire to all individuals in a certain city who are college graduates, or who earn at least $40,000 or both. Then the individuals to receive the questionnaire include those who are members of set C, okay? So here's set C, and or set S. Now, remember that or represents a union. Okay, and when we looked at Venn diagrams with compound inequalities and unions, it was everything that was listed in the Venn diagram. It's in either set. So let's continue. If we know that 40 or 4,800 individuals have college degrees, 5,400 earn at least $40,000, and 1,200 have a college degree and make at least $40,000. How many mailings do we need to send so that each person in C and S receives only one mailing? Because we don't, if we went and sent to everybody in C, all of those 4,800 individuals, and then a week later we sent to everybody in S, the people that are in the intersection would actually end up getting 2 pieces of mail. They'd get 1 piece of mail because they're college students, college graduates, and they'd get another piece of mail because they make at least $40,000 a year. So we don't want that overlap. We want to do 1 mailing, and we want each person to receive only 1 piece of mail. So this is the same type of information that we had in the last question, and we did fill out the Venn diagram. So go ahead and fill it out the way we had. I'm going to check my answers. I believe there were 1,200 in the intersection, which leaves 3,600 in C, but that's not an S. And there were 5,400 total in S. And so if there are 1,200 in the intersection, that leaves 4,200. So what do we want here? What do we want to know? We want to know that the number of, we're going to find the number of people in C or S, which is C union S. Okay, we don't want to count anybody twice. So with that, we're going to look and we're just going to add. We're going to add the numbers from this first set. And then we're going to add the number from the intersection. And we're going to add the number of people that make $40,000 but don't have a college degree. So let's go ahead and add those three numbers. Do a little mental math here. So we end up having, what, 48 and 54, 10,200 mailings are needed. And they are needed so that each person only receives one mailing, one piece of mail. Now imagine we're saving 1,200 letters, and you know that could be, that's what, 40 cents a stamp now, so we're talking a lot of money, $600 to $800. Probably $500. All right, so that would be the use, a couple of uses of the Venn diagram. So I want to look at one more Venn diagram problem. And this one involves three groups. All right, and I think these are a lot of fun, and I want us to talk about them as we move along. So let's go ahead and just start. In the survey of 110 college freshmen that investigated their high school backgrounds, the following information was gathered. 48 took mathematics, 5 took all three subjects, 8 took biology and mathematics, 10 took physics and mathematics, 45 took biology, 6 took physics and biology, and 25 took physics. And we are asked a few questions. The first question is, how many students took biology but neither physics nor mathematics? B, how many took physics, biology, or mathematics? That's that union. And C, how many did not take any of the three subjects? Now, what I just said is we're going to label these sets, but we're going to start at the middle and work our way out. Okay, so let's first start by labeling some sets here. I'm going to let M be students that took mathematics. I'm going to let B be the students that took biology. And then I will let capital P be the students that took physics. All right, so I have to have my sets defined, and then I'm going to label each of my circles. So I'm going to let math be the set on top. I'm going to let biology be the circle on the left, and I'm going to let physics be the circle on the right. So I'm going to go ahead and highlight this information as we enter it into the Venn diagram. Now, the key is to start where things are intersected first. That's where we're going to start. And what that represents would be the students that took math and biology and physics, because it is in all three circles. It's in all three. All right, so with that, let's go ahead and find the students that took all three subjects, and it's listed right here. 5 students took all three subjects, so I'm going to put a 5. Now, those 5 students that took all three subjects cannot be counted anywhere else. So now we're going to have to do a little subtraction. Okay, now where do we want to go from there? Well, we're going to go, that's like the middle. Now we're going to go to the next outer ring. And what I mean by that is the sections that are highlighted, right, or overlapped by 2 groups, by 2. All right, so I'm going to start looking at the section that is still highlighted, and that would be the students that liked math and biology. In fact, all of this piece is the students that like both math and biology. So let's go ahead and take a look for that number. So the number I have is that 8 8 took math and biology, but 5 are already accounted for. So that remains, there remain 3 out here because the total that is in that highlighted wedge has to be 8. But there were 5 students that not only took biology, they also took physics. So when you add all of the numbers in that overlapped wedge, it has to equal 8. So let's try another one. Let's look at another wedge there. I want to take a look at what is happening here. Now that overlap, that intersection is math and physics. Math and physics. So I look for a number, and here it is, students that took math and physics, total of 10. But I already have 5 counted for. So that remains 5 out here because when you add each of the numbers in the overlap, it has to equal the total that took both math and physics, and that was 10. So 5 plus 5 is 10. All right, let's take a look. There's one more section we have in this kind of like this ring of the Venn diagram. And it would be the students that took biology and physics. So when we look at the students that took biology and physics, it's a total of 6. All right, well, 5 are already in there, and I would have to write one more. Total of 6 when you add those numbers together. Okay, great. Well, our Venn diagram is looking pretty good, but I do see 3 areas that have not yet been labeled. And those are the students that took only math and not biology or physics, only biology and not math or physics, and only physics and not math or biology. So let's go ahead and take a look at what we have. So I see in this top line right here, and I'm going to change highlighting colors right there. 48 took mathematics. All right, well, when I look at this number, 48 took mathematics, the first thing I'm going to do is I'm going to say, okay, well, how many do I already have in there? I already have 13. So 48 minus 13 gives me a total of 35. There are a total of 35 students who took math but did not take biology, nor did they take physics. All right, now I'm going to go to another section, and I'm going to look at 45 took biology. All right, so here's biology total. When you add up all the numbers, we have to get 45. But I noticed that I already have 9. I already have 9. So I'm going to take that 45. I'm going to subtract my 9. And I end up with 36. All right, so out here, I'm going to write 36. It represents the number of students that took biology but did not take math, nor did they take physics. All right, I have one more. All the way out here. All right, physics. So I know 25 took physics. And I look at what I have in here, and there are a total of 11. 5 plus 5 plus 1, 11 are already spoken for. So I'm going to take the 25, because that's how many need to be in that circle, minus 11, and I have 14. So 14 students took physics, but they did not take biology, nor did they take math. All right, now that is a pretty good looking Venn diagram. And so let's go ahead and try or not try, let's go ahead and answer the questions. Okay, question A. How many students took biology, but neither physics nor mathematics? All right, well, biology, but neither physics nor mathematics. And that would be this section out here because it's in biology, but it does not overlap math, nor does it overlap physics. So I would write 36 students. Question B. How many took physics, biology, or mathematics? All right, so this is similar to the one we just did about the mailings. We're going to add each of these digits once. Okay, we're going to add them once. What does that look like? Well, let's make sure we get everything taken care of here. I'm going to move my paper up just a little bit for room. I also want to be able to see my Venn diagram. So I'm going to go ahead and I'm going to add the numbers, and I'll put a check mark after I write the numbers down. So I'm going to take 35, okay, I wrote that one, plus 5, plus 5, plus 3. And there are more efficient ways to do this, but I want to make sure we see what I'm doing here, plus the 36, plus 1, plus 14. Now notice I wrote down each number only once. All right, so they want to know how many students took any of the subjects. Didn't matter if they took more than one of them. All right, so let's go ahead and do some adding here. And I look at this and I have, I do a little bit of grouping. So 50, 90, I get 99. I'm going to check my math. Let me check it again. I might be off. I'm good. I'm good. So 49 students or 99 students. All right. Now in C, how many did not take any of the 3 subjects? All right, well, I'm going to actually remember how many total students were there? 110. So I would say 110 minus 99 gives me 11 students didn't take any of the subjects. Now, how we would represent that on this diagram is often you will see a Venn diagram boxed in, and then that 11 students would be out here. You just write it out outside of the circles, but inside the box.